Alright, we're starting 5.2 today. We've got an example here at the beginning. A Gallup poll asked 1,523 randomly selected adults if they bought a lottery ticket last year. 868 of them said yes. So Gallup poll determined that 57% of the population buys lottery tickets. So what they did was they used a sample and got information about a sample because it was doable, instead of being able to get information about the population, which is nearly impossible. This is very similar to what we did with the goldfish. We took samples and counted the number of tagged fish because we were not able to find all of the fish in the pond. So we took a sample and we got information about the sample and we applied that to the population. These are where the terms parameter and statistic come out. The parameter is the information about the population that we want to know: how many fish were in the pond, how many people buy lottery tickets, and the statistic is the information about the sample that we can find out. How many tagged fish were in your fishing sample? Or 868 of the people we surveyed said they bought a lottery ticket. So parameter goes with population and statistic goes with the sample. In the example above, the unknown parameter was the portion of the population that buys lottery tickets. This is what they wanted to know. How many people buy lottery tickets? The sample was the number of people they selected, and the statistic is the actual portion that they got with the sample. So the 868 out of 1,523. So again, statistic is usually a percentage that you find from your sample, and the parameter is a percentage you want to know about your population. The sample proportion is labeled with p hat. We're seeing that again. Remember, that was the expected value. So now it is a sample proportion. And it will vary from sample to sample because of variability. When we went fishing with our goldfish, not everybody got the same number of tagged fish because you each took a different sample. But the numbers should have been pretty close. And if we had a lot of numbers that were way off from each other, that's too much variability, and we should throw out the results and start with a different method. All right, we're going to take a look at example 1 here with Penn State University. The campus wants to know how many of their students smoke, but they have 42,000 students, so they do not have time to ask everyone. A survey was administered to 987 of the students. 43% of them said that they smoked regularly. So the population in this example is the 42,000 Penn State students. The parameter is what proportion of them smoke regularly. So that's our unknown. So there's not a number for each of these 4 things. Population, we know it's 42,000 students. The parameter is what we don't know, what portion of them smoke. The sample was 987 students. And the statistic is the percentage that you get from that, the 43%. 43% of the 987. Okay, we're going to do an activity with your heights. I asked you this question last night. What was your height? And we're going to randomly select some heights and take different samples and see how much variability we get with just doing it in our class. So if you're logging on to the Meet, that's what we'll be doing, and you can follow along with us. And I'll see you there.